Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Razi and we are doing chapter number 5, partial fractions. Students, today we are going to start exercise number 5.3 and I hope you will understand what I want to say, that you must do practice at your homes to be perfect in mathematics. So let's start. Necessary steps we have already done, but I want to revise these steps so that you can grip over these partial fractions. First of all, check whether the given fraction is proper or improper, and then in case of improper fraction, divide it to make it proper. If the given fraction, a partial fraction, is proper, then we will make the partial fractions by using a, b, c for linear factors, and ax plus b and cx plus d, so on, for quadratic factors. Remember students, if in denominator there is a quadratic factor that can be written in the form of linear factors, we will first make the linear factors and then we take a, b, c as unknown to be fine. But in case of quadratic factor that cannot be converted into linear factors, we will take ax plus b, cx plus d, and so on. So the case here in today's question is that there is no linear factor, no quadratic factor in its denominator. Remember students, if we have come to this situation when there is no linear factor or quadratic factor, we will convert it first to the to its factors. So in denominator there is x cube plus 1. We apply the formula x cube plus y cube, that is equal to x plus y into x square minus x square plus y square. So when we convert x cube plus 1 into by using the formula into its factors, we will get x plus 1, x square minus x plus 1, that is the factor of x cube plus 1. So the denominator is changed into one linear factor and one quadratic factor. So linear factor will give us a partial fraction as a over x plus 1, and the quadratic factor will be written as ax bx plus c over x square minus x plus 1. So in this way we can make the partial fractions of a linear and quadratic factor. So moving on bacho, we are now solving this rational expression, as by multiplying both sides by the denominator we get x square plus 1 is equal to a into x square minus x plus 1. The x plus 1 factor that was in denominator is cancelled out by x plus 1. So in next term, bx plus c into x plus 1, the factor x square minus x plus 1 that was in denominator is cancelled out by x square minus 1 plus 1, as we are multiplying both sides by x plus 1 into x square minus x plus 1. So we named this equation, equation number 2. Now put x plus 1 is equal to 0, which means x is equal to minus 1 in second equation. So x square minus 1 whole square plus 1 is equal to a into minus 1 square minus minus 1 plus 1 plus 0. So I have put the value of x, that is minus 1, at the place of x in equation number 2, and the second term which contains x plus 1 will be equal to 0, as we put x plus 1 is equal to 0. So remember students, the square term is always positive. So minus 1 whole square is equal to 1 plus 1 is equal to a into, again minus 1 uh, to the raised power 2 will be 1, minus minus plus, so plus 1 and again plus 1. So we have 2 is equal to 3a and a is equal to 2 over 3. Now equation 2 can be written as x square plus 1 is equal to x a into x square minus x plus 1 plus bx square plus bx plus cx plus c. Students, we write this equation in this form because we want to compare the coefficients. So in this equation there are two coefficients of x square on the right hand side and one on the left hand side, the coefficient of x square. So by comparing the coefficients of x square, we get a plus b is equal to 1. And but we already have done the value of b is equal to 1 over 3 in our previous slide. So let's see. So students, in our previous slide we calculated the value of a, that is 2 over 3 plus b is equal to 1. So b is equal to 1 minus 2 over 3. By solving this fraction 1 minus 2 over 3, we get b is equal to 1 over 3. So two values we have calculated, a which is equal to 2 over 3 and b which is equal to 1 over 3. So one value is just remaining, so we will compare the coefficients of x as. By comparing the coefficients of x, we get minus a, as the second term is minus x, so the coefficient of x over here will be minus a, and the coefficient of x is b and c in the last term. So minus a plus b plus c is equal to 0 because there is no x on the left hand side. So we solve this equation to get the value of c. The value of a is 2 over 3, so minus 2 over 3 it becomes, and b, the value of b is 1 over 3, and the value of c is to be calculated. So the equation becomes c is equal to 2 over 3. The negative term becomes positive and the positive term becomes negative on the right hand side of this equation. So when we solve 2 over 3 minus 1 over 3, we will get 3, and in numerator 2 minus 1, which is equal to 1. So the value of c is 1 over 3. In this way we have found out all the values of unknowns a, b and c. Hence the rational expression, given a rational expression, will become x square plus 1 over x plus 1 into x square minus x plus 1 is equal to the value of a is 2 over 3. We will write 2 in numerator and 3 in denominator along with x plus 1. In second term, students, we need to do some working of it because we have bx plus c. So the value of b is 1 over 3 and the value of c is also 1 over 3. So bx plus c will become x over 3 plus 1 over 3. If we take 1 over 3 common from both the terms, we will get 1 over 3 into x plus 1. And when we put this value of bx plus c in last term, we will get x plus 1 in numerator and 3 in denominator along with the factor x square minus x plus 1. So in this way we have made the partial fractions of the given rational expression. Students, in the at last I would like to say that practice makes you perfect, so you need to do practice at your homes and as much as you can. And we have started 5.3. You must do the question number 1 and 3 at your homes, and example number 1 is also included in our syllabus, so you will have to do the example 1 as well. So that's all from my side, students. Take care.